Okay, we're going to go under example 2 of solving polynomial equations. Before we do, a really quick recap. To solve a polynomial equation, we must factor it completely and set each linear factor equal to 0. Occasionally, when we are factoring completely, we end up with a quadratic that cannot be factored further. In that case, we'll use the quadratic formula. Finally, remember that the degree of the polynomial equals the number of zeros, roots, or solutions to your polynomial. So a polynomial of degree 4 would have 4 zeros. So as we move on, we'll take a look at the next example, example 2. And what I'm looking at is 125x cubed plus 216 equals 0. So I want to solve for x. The thing that I know is that I have a cubic function, and therefore I must have 3 zeros when I'm done. Now when I look at this, it doesn't look like something that's going to be easy to factor. However, I do know that I have this example, the sum of cubes, which will allow me to factor if I have a perfect cube. So what I want to do is find out, do I have 2 perfect cubes here? Well, 125 is 5 cubed. So I could rewrite 125 times x cubed to be 5 times x. And I'm going to cube that quantity. The next thing I know is that when I look at 216, that is 6 cubed. So I can rewrite that to be plus 6 cubed. Now what I notice is when I set this equal to 0, I do have a sum of cubes. That means I can factor it using the formula that we just took a look at. So that means really that what I have is 5x plus 6, and multiply that quantity times the quantity of 5x, 5 times x squared, or 25x squared, minus 5x times 6, or 30 times x, plus 6 squared, or 36. And again, this equals 0. Now I've factored this down to 1 linear factor, 1 quadratic factor. What I know about my quadratic factor is that it cannot be factored further. Therefore, what I will be doing is setting my linear factor equal to 0, my quadratic factor equal to 0, and then using the quadratic formula to finish solving. So I have 5x plus 6 equals 0. When I rewrite this, I would get 5x equals negative 6 and divide by 5. So x equals negative 6 over 5. That's one of my factors, or one of my zeros. Now when I take my cubic and I use the quadratic formula to solve it, I'll find my other 2 zeros and then I'll have my 3 solutions. But what I need to do then is to remember what the quadratic formula says. So I'm going to take a look at that. So the quadratic formula tells me that my x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. So I want to recognize what is a, what is b, and what is c. So I go back to the quadratic, and I notice that it is in standard form. Therefore, a is 25. And b is negative 30. And c is 36. Now I can take all of this and put it into my quadratic formula and solve for x. So I have x equals the opposite of negative 30, which is a positive 30, plus or minus the square root of 30 squared, which is 900, minus 4 times 25 times 36, or minus 3,600. And this whole expression then goes over 2 times 25 or 50. Now, of course, I have to simplify this, and I can't just put this in my calculator to simplify it completely because I don't know that 900 minus 3600 is going to be a perfect square, and I want an exact solution, not an approximate solution. So when I simplify, I get x equals 30 plus or minus the square root of 900 minus 3600. And when you do that, you get negative 2700. And again, the whole numerator is over 2. Sorry, is over 20, is over 50. Fix that part. Okay, I'm going to simplify this further, but I have to think about this for just a second. I have that square root of negative 2,700, and I need to simplify that. So I'm going to look at this as the square root of negative 2,700. Here are some things that I know about it. I know that when I factor this, to simplify this negative square root, I know I'm going to have an I in here. So I'm going to go ahead and look at the negative 2,700, and I'm going to factor it into 3 factors. I know that one of my factors is going to be the square root of negative 1. Now I'm looking at 2,700, and I'm asking myself, are there any factors of 2,700 that are perfect squares? And it turns out there is. So that would be the factor 900. So I have the square root of 900 times the square root of negative 1 that we already talked about times the square root of 3. Because 900 times 3 is 2,700, and then times negative 1 is the negative 2,700. Why does that help me? Because I know that the square root of 900 is 30. And I know that the square root of negative 1 is I. And the square root of 3 cannot be simplified, so we leave it as the square root of 3. Now I can go back to my quadratic, and I can do some simplifying here. So what I know is that x equals 30 over 50 plus or minus 30i times the square root of 3 over 50. Now, if you watched example 1, you'll remember why I separated it like this. I separated it to make it easier to reduce. So when I look at 30 over 50, I know that reduces to 3 over 5. So x equals 3 over 5 plus or minus, let's see if I can fix that. Sorry, that was 3 over 5. Plus or minus 3i times the square root of 3 over 5. Now, if I wanted to combine this again, I can because I have common denominators. So I could rewrite this so that it's a little bit simpler to look at. That's 3 plus or minus 3i times the square root of 3 all over 5. And because of the plus or minus, this is 2 factors, or not factors, but 2 zeros. So there we have it. X equals negative 6 over 5, and x equals 3 plus or minus 3i times the square root of 3 all over 5. So I have one real root and I have two imaginary roots.